Hi class. So today I'm going to talk to you about nomenclature, which is a fancy word for naming in chemistry. Chemists love to be fancy. They love to use words that are more complicated than they need to be. So when we look at nomenclature, there are three categories of naming. Ionic compounds are 90% of what you're going to be naming, which means if you are cramming for a test, which hopefully you're not, but if you are, focus on ionic compounds. Molecular compounds are the easiest to name, so you can learn those next. Those are only 5% though of naturally existing compounds on this planet. And then acids are 5%. They are probably the most difficult to name. If you look right here, you're looking at an ionic compound. You have a stack of ions. I haven't put the charges on here, but it's usually positive, negative, positive, negative. And they usually have different sizes, with the positive ions being much smaller. So in the ionic compounds in water, they break apart pretty easily into their ions, where negative regions will surround positive ions and positive regions will surround negative ions in water molecules. But when they're in the solid form, which is how we name them, the negative and the positive balance out. So even though those charges exist, we don't draw the final charge on them. And again, this all applies to ionic compounds. This is what we're looking at right here, and this is the bulk of the compounds that exist on this planet. This is why. This is our periodic table again. We saw it earlier. If you look right here, you have boron, you have silicon, you have germanium, you have arsenic, you have antimony, you have tellurium, you have astatine. You need to remember the staircase or the zigzag line because it separates the metals from the non-metal compounds, and these are called metalloids. Notice that not all of the names, like arsenic is AS, that one matches, but antimony is SB, that one doesn't match. I've actually had students call SB Santa Barbara on an exam, and tellurium they'll call telomeres because maybe they just took a physiology class and they're thinking of genes. So some of them come from Greek or Latin. SN10 and PB lead are two more. And they don't always match the symbols. It doesn't make sense. Carbon makes sense, it's C. Nitrogen makes sense, it's N. But there are a few that don't make sense. Those are really the ones that you need to memorize. The ones that don't make sense, and there are approximately 15 common ones that come from Greek or Latin. So the bulk of what you're going to be naming are going to come from metals, this region. Notice it includes group 1A, 2A, transition metals, lanthanides down here, and actinides down here. These actually are really rare. There are two that we learn commonly, uranium and plutonium, because they are radioactive. But a lot of these, cerium we use a little bit, but a lot of these we don't know very much about. So most of the names that you have to learn are in this area here. And again, it's the metals that we're going to focus on for the ionic compounds. Metalloids and nonmetals are named together as a molecular compounds. And that brings us to types of chemical bonds. So if you look right here, we have a covalent bond, it's water. And this is what it actually looks like, the atoms. They are more like electron clouds and they overlap. A covalent bond is a bond formed by a shared pair of electrons. And again, these are nonmetals or metalloids. Textbooks don't always tell you this, that it's a metalloid, but it includes the metalloids. Ionic bonds are attractive forces between positive and negative ions. That means it involves a metal. And textbooks don't always tell you this, but ammonium is the one ion that is not a metal that comes first in an ionic compound, which is also considered ionic because it is a positively charged ion. So a metal or ammonium would make up an ionic bond.